Hả? Cái viên phấn là tên mà đo được không?
Từ bao giờ cái
Đo được. Nếu như cái mũi tên nó nhỏ hơn viên phấn. Đồng ý không? Nhưng mà nếu mà bây giờ lấy cái này mà ném thì nó sẽ có sai số này đúng không? Có những phần không thấy ở trên, có những phần không thấy dính ở trên tường, nhưng mà thực ra không nằm ở trong cái phần này. Kiểu theo nghĩa là cái mũi tên mà muốn o thì phải nhỏ hơn phần, đúng không? Thế nên là nếu mà ông đạo diễn ấy, thay vì cho mũi tên mà bắn quả đại bác là sai số rất lớn, phi tiêu thì trúng thì sai số nhỏ. Hiểu theo nghĩa là khi mà các em đo ấy, các em phải biết là các em đo cái gì, kích thước nó khoảng bao nhiêu và cái mũi tên mà em dùng là cái gì, đúng không? Đo cái nó làm anh chết đâu, đúng không? Đồng ý không? Thì tại vì khi mà em ném như này một cái thì cái phần ở bên trên này, cái phần này sẽ là phần ảnh của ở trên tường. Em nhìn thấy phần ảnh nhưng thực ra em nhìn ảnh của cái mũi tên chứ không phải nhìn ảnh vật. Đấy, ảnh mũi tên nó mà. Đấy chính là cái philosophy. Thực ra đo là em xác định tất cả những cái điểm thuộc về vật đấy, đồng ý không? Thế mà để mà đo được thì cứ lấy tên bắn thôi, đồng ý không? Cứ tên bắn, cái phần nào mà nó thuộc về vật đấy thì tên nó sẽ dính lại. Cái phần nào không thuộc về vật đấy thì tên nó xuyên qua, cứ đến cái phần không tên xuyên qua thì sẽ ra phần còn lại, đúng không? Đồng ý không? Bây giờ tiếp theo, thêm giờ Phong bảo đây, tóc đây, đo đi. Thì đo cái gì? Ra nào? Hả? Tên bắn thì cái tên gì bắn cái tóc này? Hả? Đấy, các em phải biết cái principle đấy, đúng không? Thế thì khi người ta đưa cho các em cái tóc thì các em phải biết là anh ơi, ở trong công ty của anh có cái mũi tên là nhỏ tóc không? Có không? Thế em đo đâu? Thầy em bảo rồi, trả lương nhưng không làm được đâu. Bây giờ cho em một mũi tên nhỏ tóc. Tiếp theo nữa, thế nhỏ tóc là cái nguyên tử, đúng không? Trước đây đi học ở nguyên tử là cái thứ nhỏ nhất, không chia nhỏ được đâu. Bút láo, đúng không? Rất nhỏ thì vẫn đo được. Thế thì đo nguyên tử thì bằng cái mũi tên nào? Cái tên phải nhỏ hơn nguyên tử. Thì muốn biết tên nhỏ nguyên tử thì phải biết nguyên tử cỡ như nào thì em mới đi chọn một tên chứ, đúng không? Cái mũi hiểu trong cái mũi tên càng to sai số càng lớn, đúng không? Cái này là muốn bán nó chính xác, tay thì nhỏ thôi. Đó, tay sai nhiều khi bạc quá đầu, tay to nhiều khi bạc quá đầu. Okay, so that's the philosophy of measurement. Okay, so we define all the point belong to object. So here, for example, if you have this one, you take this crystal, big like this one, right? And your boss say that, can you do the measurement to tell me what would be the weight of this one? What do we do? We ask for a balance. We put inside, so you have balance. Okay? So we will finish. But now, if you have an object like this one, with the size of about 1 per 1,000 times of the hairs I have. If extremely small like this one, this object, let's say few nanometer, very small, how can we define the mass, the weight of this one? Các em hiểu không? Không thể có. So how can we do? But microscope, you see the size, not the weight. So how can we do?
đo cả một cục và đếm được cả.
Hả?
Đo một cục và đếm được cả. Đếm bao nhiêu cả chia cho mình.
Okay. Assume that this object is made of calcium carbonate, CaCO3.
I think we can try to compare what we are measuring with something we already know, the mass.
But we know not to How you can calculate the number of molar of calcium carbonate here in this case? You heat it up, calculate the number of molar CO2, right? But you are crazy, we cannot be able to calculate that. Too small. So how can we do it? Huh? Huh? Ok, đồng ý với thầy là học to ra thì cân dễ đúng không? Vẫn cân. Ok. Thế nhưng mà cái mặt bè tùy còn cái tóc thì cân kiểu gì? Còn nhỏ tóc thì cân kiểu gì?
Thầy nói là có lượng zit nhưng mà làm biết được có lượng zit thì không biết được lượng.
I think we think the whole the entire component and measure and then divide.
Một cụm này có bao nhiêu chia chúng nó?
Calculate so
Anyone? I give you information to say that this object is calcium carbonate. If you have this object of calcium carbonate, you know what to be the mass already, right? You put in a balance. But if you have the side extremely small like that, what you know is made of calcium carbonate. So you know about the density, right?
Yes.
Is it correct or not? The density equal to m over v. Okay?
Yes.
This one you know. Okay? So if you know this, you could be able to define the mass by d times v. So now the problem is that how can you define the volume of this one? It's extremely small.
Microphone.
You need to explain it. Understand? Okay? So, imagine that you have an object like this one, and the thing you use is electron. So you send an electron to the subject, to the object. When the electron hits the object, it will be back, right? So you see this. All the electrons you flow through, it will not be back. So you know the point which is not belong to object. Is it correct or not? Imagine this guy small like this, okay? And this is my electron. Okay? I do like this. So, and I put a spring here. When electron hit, it will give a bright one. And if the electron can hit, I know that this direction, this point, will not belong to this guy. Okay? Because if it hits this one, I cannot see in the screen later. Is this clear or not? So by doing so, I can have the sign of this one. But imagine, if this guy is not solid, inside he has some volume. How can we know? Because by doing like this, the size of this balloon, whether it's empty inside or not, will be the same. Đúng không? Cái quả cầu nó rỗng hay không rỗng, khi mà thầy ném nó cũng cho kết quả giống nhau à? Đó. Tên này một nửa nó chống, người trong người nó chống, em nhìn thấy cái phần nội tạng bên trong thầy nhìn thấy thì chỉ nhìn thấy kích thước từ cái phần electron bắn về phía đằng sau thôi, đúng không? So now imagine that this object is not the bulky one, but with empty inside. Okay, a lot of gravity inside. How can we define the volume of this one? Huh? You get what I mean? This, because if you take the wrong volume, it will give the wrong mass. Because the D density will be the same. Okay? If the object is this guy, is solid, without any volume inside, without any empty inside, it will give the correct answer. But if this guy has some volume, big volume inside, this morning he has not eaten anything, so the volume is big, then we will give the wrong answer. Okay? So now imagine the last question I have. Imagine that this object is empty inside. How can we define the volume of this object? So exactly to know the volume of calcium carbonate. To tell you very simply, to answer this question, the researcher from France, they published in Nature to see how it's difficult. So they invite the support from IT guy. Here you need to have IT guy. When you take the photo at a different angle, you see some bright area and dark area, right? So here you see the bright area and dark area. So by spinning around the object like this, you know on the bright point and the dark point. So by the image processing, like we call the image processing, you know on the bright point belong to the object and the dark point belong to the environment design. So by collecting on the right side like that, right point like that, so they will be able to define the volume of this one. So where the IT guy, ICT, machine learning is extremely important. Okay. So very quick. When you talk about the measurement, so you have 7 units of measurement. So system international unit. So SIE, International System Unit. So you have length, which is mass, time, electric current, temperature, amount of substance, luminous intensity. Okay, so there are the 7 key SIU unit. And you have some prefix, for example, mega is 10 power 6, kilo is 1000, DC 0.1, and so on. We have. And we have different scale to calculate the temperature. For example, you use the Kelvin scale, you use the Fahrenheit scale, how we convert from Celsius, degree Celsius to Kelvin, how we can convert from Fahrenheit to Kelvin, and so on. It's quite easy. And beside the 7 units, you have some derived unit. For example, volume. Volume, you take length, multiply length, and another length, right? You have a density, so you take the mass, you divide by volume. You have a charge, so it's the amount of the electricity goes through the current during 1 period of time. So there one video. So we talk about what we call the exact number and inexact number. Exact number is those numbers who have value are exactly, and we know. For example, a dozen of eggs is 12 eggs. There's no problem. But when we say that inexact number are those who value have some incertainty. For example, all the numbers from experiment are inexact because you have incertainty in your measurement. So the question where you come from with the 15.5, 15.4, 15.6, or even like crazy, I say the 20. That's I demonstrated. Okay. The error from the measurement can come from the equipment error. Systematically, whoever you stand to do the measurement, you will have the same error. Or the error from the human, for example, myself, when I compare with this colleague, he said that 15.5, I say 20, so it's the human error, okay? So, you have the concept of precision, that means you repeat the different number of measurement, how the X measurement can be reproduced each other. I mean, how can you get comparable result? Okay? And the accuracy is that how the measurement you have close to the correct value that people know. So let's say the gravity constant is not 0.98, right? So, and you say that, okay, I get the measurement 0.95, so that means it's quite far from the exact number. Just with the condition that the number 0.98 is no, everybody accept. So you have a different image here. Let's say you have a low accuracy, no precision, or you have high accuracy and high precision. In ideal case, if you have a measurement in this way, it will be perfect. But most of the time, you will not get it wrong. That means you repeat all the time the same result, and the result you get very close to the real result. But most of the time, when I say, you will not get it. So most of the time, you would prefer this one. That means the measurement you have can be very far from the reality, but each time you do the measurement, you will have the same result. So, by that way, you do the calibration, you can get the real result easily. So another example, another demonstration to show what could be the precision and the accuracy. So here you have the reference value, that means the value people understand, people accept. And here you have the low precision, that means each time you repeat the experiment, you can run from here to here. And if you have excellent precision, that means you have all the time at the same position of the result. Then you have the position of result different from the reference number. We call the low the accuracy. What I want to say is that most of the time in our research and research development life in industry, we don't know the reference number. Okay? It's a philosophy question. And here are the slides you learn. In the philosophy you learn, I don't know whether you learn. In the philosophy there is one question, whether human being can know everything. Whether we are able to understand the nature. There is one direction, one philosophy to say that no, we are not able to understand everything. There's something mysterious. Mystery, we could not be able to understand. Another philosophy to say that human beings are extremely smart is that's a question of time. We understand everything. Okay? So let's say if we cannot understand everything, then forget. We don't try to do the measurement, the thing we cannot understand. Okay? No one tries to measure the mass, the volume of God. Imagination, we understand that we are not able to understand. We follow, we believe, but we don't understand. If we say that, yes, we can understand, then the matter is that the development of our understanding will be not a linear like this. Today you are here, tomorrow will be here, and tomorrow after will be, the day after will be here. The development of your understanding will be like this. So each time you do the measurement, it will reach the reality. It will reach closer to the reference value. But in principle, it will be never to reach exact reference value. You got what I mean? So the development of the science is that today you get, let's say, 10% error with the reference value. Tomorrow you get 5%. The day after you get 1%. So that is development. But you will never reach a level when you have 0% of the uncertainty, 0% of the error compared with the reference value. Because the reference value you can reach, but you cannot achieve. You get what I mean? So, all other points are quite easy to understand. Let's say how you calculate, how you define the significant figure. It's a slide already. And what could be the rule you calculate for the number of significant number. And you will work on this during the tutorial class. So, I finished here the third section about the matter and measurement. Basically, we discussed about the classification of matter, we talked about the physical, chemical quality, physical, chemical change, we talked about energy, we talked about the measurement, the principle of measurement, what could be the error, and how we can solve the problem. Okay? Do you have any question for the two class? Any question? The way I explained to you about the concept, is it understandable? Okay, then thank you.